We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system. Take a look. The striking infrared images were taken this summer by the James Webb Space Telescope.
First of all, it's really gorgeous, and it's teeming with galaxies. And that's something that has been true for every image we've gotten with Webb.
Out in the farthest reaches of our star system, where light fades and the void stretches endless, humanity's most advanced observatory scans the heavens, seeking clues to the universe's birth and the possibility of distant worlds. Designed to capture the glow of ancient stars and the atmospheres of far-off planets, it has unveiled wonders beyond imagination. But now, it has stumbled upon something far stranger, a fleeting, encrypted signal buried in its data stream, pulsing with mathematical precision from the shadowy edges of our cosmic neighborhood. This wasn't a natural hum of the cosmos. It was structured, deliberate, as if crafted by a mind we can't yet fathom. Has this telescope caught the first whisper of an alien presence, or uncovered a phenomenon that rewrites the rules of the universe? The discovery has sent shockwaves through science, and we're only beginning to grasp its meaning. Before we unravel this chilling cosmic enigma, smash that like and subscribe for more mind-blowing updates from the stars. The observatory, stationed a million miles from our world, is a triumph of human ingenuity, its sensitive instruments tuned to detect the faintest traces of infrared light from across the cosmos. It was engaged in a routine survey, studying the atmosphere of a distant planet in another star system when an anomaly slipped into its data stream. Buried among the expected telemetry, readings of gases, temperatures, and stellar light, was a signal unlike anything seen before. It wasn't a random burst of cosmic noise or a glitch in the system. It was a narrow band of pulses, arranged in a complex, mathematical sequence that defied natural explanation. At first, scientists suspected interference, perhaps a fault in the observatory's delicate sensors. But as they dug deeper, the anomaly only grew stranger. The signal's pulses formed a fractal pattern, repeating in intricate, layered loops that suggested not chaos, but design. It wasn't the steady rhythm of a pulsar or the static of a distant galaxy. It was recursive, almost responsive, shifting slightly when probed with different frequencies. This wasn't just a signal. It felt alive, as if it were listening, adjusting, waiting. The discovery triggered a flurry of activity, with data analysts isolating the signal in secure networks, shielding it from public view while they grappled with its implications. What made the signal truly unsettling was its origin. Tracing its path revealed it didn't come from the distant planet under study, 1,200 light-years away, but from much closer, a remote region at the outermost fringes of our star system, where icy debris drifts in near-total darkness. This was a place thought to be silent, inactive, a graveyard of frozen remnants from our system's birth. Yet the signal suggested something active, perhaps intentional, lurking in that distant void. Was it a reflection, bouncing off an unseen object? Or a deliberate transmission, sent from something positioned to watch our system from afar? The signal structure was unlike anything in our scientific records. Its fractal repetition, weaving complex patterns within patterns, resembled a code built on universal mathematics, not human language. It carried no words, no images, just pure logic, as if designed to be understood by any mind capable of recognizing it. The pulses reacted subtly to the observatory's probing signals, shifting their rhythm in ways that suggested interactivity, not randomness. Imagine a cosmic beacon, not shouting into the void but whispering, waiting for a mind advanced enough to hear it. Could this be a test, a challenge to prove our technological worth? The scientific community was stunned. For decades, the search for life beyond our world has relied on scanning for obvious broadcasts, radio waves, light flashes, signals meant to be found. But this was different. Subtle, hidden, embedded in routine data. It wasn't a loud declaration, but a quiet puzzle, demanding we notice it. The observatory, built for peering into deep space, wasn't designed to detect such signals, yet its unmatched sensitivity had caught something no other instrument could. The realization hit hard. If this was intentional, it was meant for someone or something with tools as advanced as ours. Initial theories leaned toward terrestrial explanations. Could it be a forgotten probe, a relic of an old mission sending degraded signals? But no record matched the signal's complexity or origin. A satellite malfunction? The fractal patterns and reactive nature ruled that out. The more analysts studied it, the more it pointed to something extraordinary, perhaps an artifact, a probe, or a node left in the dark, silently collecting data until we stumbled upon it. The idea was both thrilling and chilling. What if this signal wasn't meant to be found yet, and our detection was an accident, a premature glimpse into a larger cosmic game? The signal's isolation in encrypted networks only heightened the intrigue. Whispers from within the scientific community hinted at urgent meetings, with experts in cryptography, quantum computing, and astrophysics brought together to decode its patterns. Other observatories, from radio dishes to underground detectors, were quietly redirected to the signal's origin point, searching for echoes or anomalies. Faint, coincidental signals began to emerge, not as clear as the observatory's data, but aligned with the same distant coordinates. Was this a one-off event, or part of a network of silent watchers scattered across our system's edge? The implications were immediate and profound. If this signal was natural, it revealed a phenomenon beyond our current physics, a process that mimics intent with uncanny precision. If it was artificial, it suggested a presence, ancient or active, lurking closer than we ever imagined. The observatory's accidental interception turned a routine mission into a cosmic turning point. What else have we missed, hidden in the noise of the universe? Was this the first signal, or merely the first we've noticed? The cosmos, once a distant frontier, now felt alive with unseen possibilities. The encrypted signal, intercepted by humanity's most advanced observatory, has shattered the silence of the cosmos. Its fractal pulses, woven with mathematical precision, pulse like a heartbeat from the distant fringes of our star system, a region we thought was a silent void. This wasn't a random cosmic hum. It was structured, reactive, as if designed to test our ability to listen. Its discovery has sparked a global frenzy, with scientists and cryptographers racing to decode its meaning, while whispers of an alien presence grow louder. Was this a deliberate message, a relic of an ancient intelligence, or a phenomenon beyond our physics? The signal's fleeting presence, now silent, leaves us grappling with a universe that feels more alive, more watchful than ever before. What did we stumble upon, and are we ready for what comes next? The signal structure is unlike anything in our scientific arsenal. Its fractal patterns, repeating in intricate, self-similar loops, suggest a complexity that transcends natural processes. Pulsars emit steady beats, cosmic rays scatter noise, but this signal was recursive, shifting subtly when probed, as if responding to our scrutiny. Picture a cosmic puzzle, its code built on universal mathematics, waiting for a mind sharp enough to solve it. The pulses carried no words or images, only pure logic, a language that could speak to any intelligence capable of hearing it. Yet its reactivity, adjusting to our probing frequencies, hinted at something more, a system that listens, adapts, perhaps even observes. Could this be a beacon, designed to signal when noticed? The signal's origin, traced to the outermost edges of our star system, deepens the enigma. This region, a sparse cloud of icy remnants, was thought to be dormant, a relic of our system's birth with no activity to speak of. Yet the signal suggested something active, perhaps intentional, lurking in that darkness. Was it a reflection, bouncing off an unseen object? A probe, stationed to watch our system? Or a node in a vast, unseen network, relaying data to an unknown recipient? The observatory's sensitivity, unmatched by any other instrument, caught what others missed, but its fleeting detection left us with fragments, a single spark in the void, now gone silent. What else lies hidden, waiting for our next glance? The scientific implications are seismic. The signal challenges our understanding of the cosmos, revealing gaps in our ability to detect subtle, structured phenomena. For decades, we've scanned for loud broadcasts, radio waves, light bursts, expecting alien contact to be overt. But this signal was covert, embedded in routine data, demanding advanced technology to even notice. It forces a rethink of how we search for life, pushing us to tune our instruments for mathematical patterns, not just energy spikes. Observatories worldwide are recalibrating, redirecting their gaze to the system's fringes, searching for echoes of similar signals. Archival data from past missions, probes, telescopes, even decades-old sensors are being scoured for overlooked anomalies, hints of other whispers we dismissed as noise. The signal's reactivity is particularly baffling. Its subtle shifts in response to probing frequencies suggest a dynamic system, not a static recording. This wasn't a dead message, etched in time. It behaved like a living algorithm, adjusting to our presence. Some scientists propose it could be a natural phenomenon, an exotic process mimicking intent, perhaps tied to unknown physics in the distant reaches. But the fractal complexity and mathematical purity lean toward a bolder hypothesis, an artificial construct, a beacon or probe designed to test our technological maturity. If so, its silence after detection raises chilling questions. Did it stop because we noticed it, or was it programmed to transmit only once, a cosmic challenge we've now answered? The global response has been intense and guarded. The signal, isolated in encrypted networks, sparked urgent collaboration among the world's top minds, astrophysicists, cryptographers, even quantum computing experts. Faint, corroborating anomalies from other instruments, radio arrays, underground detectors, hint at activity aligned with the signal's coordinates, though none match its clarity. Behind closed doors, governments and private institutions are sharing classified data, driven by a shared need to understand. The public hears of stunning planetary images, but the real story, this cryptic pulse, remains shrouded, fueling speculation about what's being hidden. Are we on the cusp of a breakthrough, or guarding a truth too big to share? Philosophically, the signal redefines our place in the cosmos. We've long seen ourselves as explorers, casting our gaze outward, assuming the universe waits for our discovery. But this suggests we're also the observed, our technology just now sharp enough to catch a glimpse of something waiting. The signal's mathematical nature feels like a test, not a greeting, a challenge to prove we're ready to join a larger cosmic conversation. If it's artificial, it implies a presence, ancient or active, that's been watching, perhaps for millennia, silent until we crossed a technological threshold. Are we players in a game we didn't know we joined, or mere passers-by in a universe alive with unseen watchers? The cultural impact is electric. The idea of a signal, hidden in our own star system, flips exploration into encounter. It's not a distant star or galaxy. It's here, in our backyard, a whisper from the shadows. The absence of a follow-up signal only deepens the mystery, suggesting a purpose we can't yet grasp. Was it a one-time test, triggered by our observatory's gaze? A relic of a civilization long gone, or a probe still active, relaying data to an unknown source? The silence feels deliberate, as if the sender is waiting for our next move. This isn't just science. It's a story of humanity standing at a cosmic crossroads, unsure whether to shout back or listen closer. The signal's implications stretch to the future. New missions are being proposed, probes to explore the system's fringes, telescopes tuned for mathematical signals, AI systems to decode fractal patterns. The discovery has sparked a surge in funding, with governments and private sectors uniting to chase this mystery. If this was a test, passing it means rethinking our tools, our theories, even our place in the universe. Could there be other signals, buried in the noise, waiting for us to find them? The observatory's accidental discovery has turned a routine mission into a clarion call, urging us to look deeper, to question what we thought we knew. As the signal's echo fades, the questions grow louder. Was it a lone artifact, or part of a network we're only now glimpsing? Did we trigger something by detecting it, or were we meant to find it all along? The cosmos, once a vast canvas for our exploration, now feels like a stage, alive with possibilities we can't yet name. This signal, a fleeting pulse from the dark, has changed everything, reminding us that the universe is not just out there. It's here, watching, waiting, whispering. If you're as stunned by this cosmic puzzle as we are, smash that like button and subscribe for more updates from the edge of the universe. Leave your comments below and tell us what you think this signal could mean. Alien test, ancient relic, or something beyond our imagination. We want to hear from you. Thank you for joining us on this journey into the unknown, and we'll see you in the next stellar adventure.